Welcome to System Design Fundamentals, a practical introduction to essential components like blob storage, CDNs, message brokers, and distributed systems. We'll explore how and why these crucial systems work, focusing on the underlying principles for developers. A blob, or binary large object, is the binary representation of files like MP4s or PDFs, stored as zeros and ones. To avoid slowing queries and complicating scaling in databases like MySQL, use a managed blob storage service, which handles scaling, security, and backups. Examples include AWS S3 and Cloudflare R2. A WSS3 offers cloud storage at scale. It is cheap, durable, and infinitely scalable, making it much more cost-efficient than RDS for storing large amounts of data. S3 boasts automatic scalability, an 11.9's durability guarantee, pay-as-you-go pricing, and strong security features like encryption and IAM policies. Content Delivery Networks, or CDNs, address high latency when files are stored far away from the user. A CDN caches content on geographically distributed edge servers, serving users from the nearest location. Key components include edge servers, origin servers like S3, TTL for cache control, and GeoDNS for routing. For asynchronous processing of long-running tasks, such as video transcoding or sending emails, offload the work to background workers via a message broker. The workflow is simple. The producer posts the task, the worker pulls the message, and then the worker deletes the message. This decouples services, allows for retries, and enables independent scaling. Apache Kafka is a high-throughput message streaming platform, ideal for scenarios requiring, quote, write once, read by many. It involves 4 core concepts. The producer publishes messages to a Kafka topic, which is divided into partitions for parallelism, consumed by consumer groups that process partitions independently, and managed by brokers which store and manage the topics. Event-driven architecture, or EDA, allows services to emit events to a message broker and react independently without direct coupling. For example, an order service publishes an order-placed event, which inventory and notification services consume asynchronously. Events can use simple event notification or event-carried state transfer. A distributed system uses multiple machines to handle work, providing the illusion of a single machine to the client. Leader-follower is a common pattern, where one leader assigns work. Consistency models determine when updates are visible. Strong consistency requires all replicas to agree before acknowledgement, ensuring low availability. Eventual consistency allows replicas to converge over time, prioritizing high availability. Proxies, pub sub, and auto recovery are critical networking concepts. A forward proxy acts on behalf of the client, while a reverse proxy acts on behalf of the server. Real-time pub/sub brokers push instant messages to subscribers. Auto recovery uses an orchestrator to monitor servers and restart failed ones, ensuring fault tolerance without manual intervention. To approach any system design problem, start by clarifying requirements. Next, break the problem into manageable subproblems, such as product listing or payments. Then, design each subproblem by selecting the appropriate database, caching, scaling, and communication methods. Finally, iterate and refine. Remember to use proven tools and focus on your business logic.